Hello and welcome to another RouTube video. In this video I will be covering how to find the interquartile range in multiple ways, including using the CAS calculator. Students are introduced to the interquartile range in Year 10 and continue to develop their knowledge up until Year 12 further maths. So a few learning objectives for this video. The first one is to use our prior knowledge on quartiles to get an understanding of the interquartile range. The second one is to understand how to calculate the interquartile range from a dot plot. The third learning objective is to understand how to calculate the interquartile range from a box plot. And the final one is to find the values of the lower quartile and upper quartile using the CAS calculator. Okay, so before we get to the interquartile range, we need to know about quartiles. So what are quartiles and what do they do? Well, quartiles divide a data distribution into quarters. So the first quartile is the midpoint of the lower half of the data, which we refer to as Q1. We then have the second quartile, which is the middle data value, which is referred to as either Q2 or the median. They are the same thing. And then the third quartile is the midpoint of the upper half of the data values, which we refer to as Q3. All right, now let's turn our attention to the interquartile range. So what is it? So the interquartile range is a measure of the spread of a distribution that includes the middle 50% of the data values. Okay, so this is really closely aligned to box plots, which we're going to have a look at a little bit later. So if you need some more information on box plots and sort of seeing that middle 50% of the data values, feel free to jump over and have a look at my box plot video as well. How do we calculate the interquartile range? So we have a simple formula. It's just Q3 minus Q1. Okay, so Q3, as we saw previously, is the upper quartile and the Q1 is the lower quartile. And we're going to go through how to find that by hand and on the CAS calculator shortly. Now, something really interesting and something that sort of often pops up in a SAC or an exam style question, or just sort of as you're sort of progressing through this unit, is when they compare the interquartile range to the range. Okay, so they're both measures of spread, but we do actually prefer the interquartile range. And sort of this little paragraph, mini paragraph here, just explains why we prefer to use the interquartile range as opposed to the range. So let's have a read through. So as the range depends on only the two extreme values, which is the minimum and the maximum, if you can recall, to calculate the range, it's just the maximum minus the minimum. So as the range depends on only those two values in the data, it's not always an informative measure of spread. For example, one or the other of these two values might be an outlier, okay, and that's going to sort of give a misrepresentation of the spread, or it could give a misrepresentation of the spread. Furthermore, any data with the same highest and lowest values will have the same range, irrespective of the way in which the data is spread out in between those two values. Okay, so for this reason and for both of those reasons and everything I've just said, the interquartile range is a much more refined measure of spread as it overcomes the above listed limitations. Okay, so before we actually have a go at calculating the quartiles and then calculating the interquartile range once we have those quartiles, I thought I'd just list out a few steps that you can follow that will assist in finding the quartiles if you don't have a CAS calculator, or if you just want to have a go without the CAS calculator. Obviously, the CAS calculator will assist you, which we'll go through in a second, in finding the quartiles, but these steps, as I said, will help you without the CAS calculator. So the first step is to order the data set in ascending order, so from the minimum value to the maximum value. We then have to find the median value, which we know is Q2. If you need any assistance on finding the median, please feel free to check out my median video. Then once you have Q2, split the ordered data set in two halves, so sort of one to the left and one to the right. The lower quartile, which we know is Q1, is the median of the lower half of the data, which you've already spoken about, and that means that the upper quartile is the median of the upper half of the data. Now let's have a go at actually putting that into practice. All right, so now let's find the interquartile range. So we have this question here. The following data set represents the amount of birds spotted flying on each day of a 13-day tour of Queensland. And then we have all our values there. And you can clearly see that if if you have a sound understanding on outliers, there's probably an outlier in this data set, but we're not going to focus on outliers. That is on another video. So our job is to find the upper and lower quartiles, so Q1 and Q3, or Q3 and Q1 respectively. And then once we have that, then to find the interquartile range. So we're going to follow the steps that we spoke about previously. So step 1 is to order the data in ascending order. Okay, so now that we have ordered the data in ascending order, now we can then proceed to step 2, which is to find the median value, which is Q2. So I might just do that just up here. So if we remember, to find the median, it is the n plus 1 over 2. Remember, that tells us where the median is, not what the median is. Okay, so n is the number of data values that we have. In this case, it's going to be 13. So it's going to be 13 plus 1 over 2. And that becomes 14 over 2, which becomes 7th. So that means that the median is the 7th value. So now we can simply just count 1, 2, 3, 4, 5, 6, and 7. Okay, so I might just highlight that in yellow. So that value of 4 is our Q2. That is our median value. But we know that that's not what the question's asking. Okay, but it's going to help us to work out what our Q1 and Q3 values are. Okay, so step 2 is completed. Now what we need to do. Step 3 says at Q2, so at the median, split the ordered data set in 2 halves. So essentially where that median is, we've got 1 half which is on the left and 1 half which is on the right. Okay, so we have that clearly seen there. Then step 4 says the lower quartile, which is Q1, is the median of the lower half of the data set. Okay, so what we're going to do, we're just going to focus on the values over here. So we're going to focus on the left-hand side of the data. Okay, so we need to find the median of the lower half of the data. So once again, we're going to use the same formula that we used before, okay, to find the median of that section, the lower half. So we've got n plus 1 over 2. And in this section here, n is no longer 13 because we're only talking about the lower half of the data. So n is now just 6 because there's only 6 values. And that becomes 7 over 2, which becomes 3.5. So that means the median of the lower half is the 3.5, or between the third and the 4th value. So we can then count, and I'll do it in green. So 1, 2, 3. So smack bang right between those values there. So right between 2 and 2. Well, clearly there's no value between 2 and 2. So therefore we can confidently say that the value of Q1 is equal to 2. Now we need to do the same thing, and I'll do it in blue. We need to do the same thing for the upper half of the data. So we're now going to go from this side all the way to this side. Okay, so once again, we don't really need to do that calculation again because we know that there's 6 values. So we know that the median of the upper is going to be the right between the 3rd and the 4th value because we just did it. So now we've got the 1st value, 2nd value, 3rd value, and 4th value. So it's right between 5 and 6. Okay, so you can either just come up and say, well, what value comes between 5 and 6? Clearly it's 5.5. Or you can actually do it like so. So you can work out 5 plus 6 over 2, which is equal to 11 over 2, which is equal to 5.5. Okay, so therefore our Q3 is equal to 5.5. Okay, so that's our part A completed. Now we'll do part B on the right side. Now part B is going to be quite simple because remember, to calculate the interquartile range, it's simply just Q3 minus Q1. And we know what our Q3 is, it's 5.5. And we know what our Q1 is 2. So therefore our interquartile range is 3.5. All right, now let's have a go at doing the exact same question, but on the CAS calculator. So just to save us a little bit of time, I've just entered in the values. Now you clearly see I have entered them as they are written. I have not put them in ascending order because as I've spoken about previously on other videos, your CAS calculator is quite smart and
actually orders the data for you when it does a stat calculation, which is what we're going to do. Okay, so like I said, I've entered all the values in, which we can clearly see if we make our way down. Now this little number, that's really important. It's really important to always check that whenever you're entering in a list and spreadsheets, because that's our value of n. Okay, so that means that there are 13 values in our data set. Okay, so let's just say, for example, the final value was 2 and n was 12. Well, we can clearly see from the question that there should be 13 values. So you can go back and say, well, I've actually missed out on a data value. Okay, so that's a good little way to double check. And as always, whenever you're entering values in lists and spreadsheets, we always need a column heading. I'm just going to call it geese because this question, no, it wasn't talking about geese, it was talking about birds. Sorry, let me just rewrite that. We're just talking about birds. But once again, doesn't matter what you give as the column heading. So stat calculation as per normal, statistics, stat calculation, and then we are looking at univariate, which means 1. So one variable statistic, that's always 1. And then in that top box, we've got birds and geese. Obviously geese, we won't use that because it doesn't have any data anymore. So whatever you called your column, I called it birds. So therefore, we just press OK. And once again, a lot of information comes here. Okay, so we've got our mean. We don't need any of that information. The only two pieces of information we need for this specific question is here where we see Q3X. Okay, so Q3X, that's your upper quartile, your Q3 value, which is 5.5, which we calculated previously, and our Q1X, which is your lower quartile, which once again we calculated as 2. So it's important to note, your calculator doesn't actually tell you what your interquartile range is, okay? But it does give you the value of Q3 and Q1, okay? So I'll say that again, your CAS calculator does not actually give you the specific value of the interquartile range, but it does give you the value of Q3 and Q1. And then you simply just go to the formula Q3 minus Q1, and that's the value of your interquartile range, which we can clearly see is 5.5 minus 2, which should give you 3.5, which is what we calculated without the CAS previously.
All right, let's have a go at finding the interquartile range, the IQR, from a dot plot. So find the IQR from the dot plot below. So as the values are already in ascending order, we can proceed to find the median first of all. So remember, to calculate the median, it's going to be n plus 1 over 2, which in this case, n is, as always, the number of values in the data set, which is going to be 19. There are 19 values. So 19 plus 1 over 2, which is 20 over 2, which is 10. So the median is the 10th value, which we'll write there. The median is clearly not 10. It's the 10th value. So then we can go through from left to right, and we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there is our median value. That is the middle value in this given data set. So the median value is 4. That value that we have circled is 4. Then, as we know, we need to find the median or the middle value of the lower half of the data. Okay, so what we do from there is we count how many values are there in the lower half, which we'll do from here to here, which we might do in red. So we've got 1, 2, 3, 4, 5, 6, 7, 8, and 9. So then to calculate the median of the lower, we're going to do the same thing again. So now it's going to be 9 plus 1 over 2, which is 10 over 2, which equals 5, which is the 5th value. So that means we're going to go through, I'll get rid of these little red ones so we can mark them off again. We need to count and find our 5th value, and that's going to be our Q1. That's going to be the median of the lower half of the data. So we've then got 1, 2, 3, 4, and 5. So there's our Q1 value, which we will just write up here so we don't forget it. So Q1 is equal to 2. Now we'll do it in green. So now we've got the upper half of the data, which is going to be, we're going to find our Q3. So then once again, to find the median of the upper half, it's going to be n plus 1 over 2.
Now we know there should be 9 values because it was the same for the lower half. Let's count them again. We've got 1, 2, 3, 4, 5, 6, 7, 8, and 9. Yep, we've double checked. So we've now got 9 plus 1 over 2, which is then going to be 10 over 2, which is then going to be, once again, our 5th value because we split the data in half with the median. So then now, once again, we can count from the median to our 5th value. So we've then got 1, 2, 3, 4, and 5. So then our Q3, which we've got in green, is going to be 5. But that's not what the question asks. The question wants us to calculate the interquartile range, which we'll just do down here. So the interquartile range we know is Q3 minus Q1. And we know our Q3 value, we just found it, is 5. We know our Q1 value, we just found it, is 2. So therefore our interquartile range is 3. Okay, so this will probably be the easiest question that you'll do, that we'll go through in this video. And it's the easiest time to find the interquartile range if you have a sound understanding of box plots. So this question says, find the interquartile range from the box plot below. And we're given a box plot. Clearly, we've been given the scale is from 0 to 100, and it is representing a class's maths test results. And once again, we've been given a box plot. Now, we've also been given specific values in the box plot. Now, remember, again, if you need some assistance with the box plot, please feel free to jump on my box plot video and check it out. So a box plot is just a visual representation or a graphical representation of the 5-figure summary, okay? Which, if we have a look here, the value of 8 is just our minimum value. The 32 is our Q1 value. The 55 is our median, which we know is our Q2. 67 is our upper quartile, which is Q3. And then our 92 is our maximum value. Okay, so that is something that you are expected to know about box plots. So then if we go back and we say, well, what are we actually asked in the question? Well, we're asked to find the interquartile range. And we know the only two numbers we need when we are calculating our interquartile range are Q3 and Q1. So therefore, let's just start with writing the formula. So we've got interquartile range is equal to Q3 minus Q1. Now the value of Q3 is 67, which we can clearly see, and then the value of Q1 is 32. So therefore, if you need to use a calculator, go for it. Otherwise, 67 minus 32 should be 35. So the interquartile range of this specific data, the middle 50% of this data set, is 35. Thanks so much once again for tuning into another RouTube video. If you learned a thing or two about interquartile range or box plots or the CAS calculator or all of the above, please feel free to show me some love and like and subscribe to my YouTube channel and to the video. And please feel free to check out similar videos relating to median, box plot, and anything else that you'd like to check out. Catch you next time.